Hi, everyone. I'm Deon. I'm very excited to be doing my first podcast for Made Brief. I'm CTO at Made Brief, and I've been with the company for 7 years. Really love working at Made Brief and very excited to talk about today's topic, debunking some AI myths and talking a little bit more about how technology fits into the clin-neg space.
Hi, I'm Laura. I'm the AI lead at MedBrief, and I'm very happy to be here to talk about AI.
Laura, I think it's a good idea if we just maybe tell everyone a little bit about what we do at Made Brief. So as CTO, I know there's maybe a bit confusion. Am I just a business person? Am I just a coder? I guess it's a little bit of both. One of the things that I've realized in my role as CTO is that you don't have to be the best coder in the company. In fact, it's your job to find the best coders out there and bring them to the company and make sure that you consistently build software that supports the business, as well as using the right technology that supports the business. So yeah, that's something I think is quite interesting about the role. Anything you want to explain about what you do at MadeBrief?
Yes. So actually, someone would think that an AI lead would be just all the time building AI, but that's not the case. Lots of time is taken into making sure that we can translate the problems into useful AI tools, because the idea is not just to build AI because of the hype or just build for building, but actually have something that has an impact for the end user, for the clients, and making sure that it's responsible, that we're doing it in an ethical way. It's not just throwing an LLM at it, as most people would think of when you're building AI, but it's an entire life cycle, an entire framework that you have to make sure that you follow when you are in this kind of high-risk environments like the medico-legal one in MedBrief.
Yeah, and we often talk about how what we build has a material effect on people's lives because behind our data, there's real people. And it's something we always have to keep in mind as well. Cool. Should we dive into some of the myths of AI? I think one of the common misconceptions that people have is they don't really understand what AI is, or they think it's a very new technology that's all of a sudden come out of nowhere. But you and I both know it's been around for a really long time, or the stuff that makes up AI has been around for a really long time. Do you have any insight into that?
So actually, the mathematical models in AI were developed a long time ago, many years ago, decades. The thing is that at that moment, computers didn't have the power in order to solve these mathematical problems in an efficient way, and we didn't have enough data. Then with the internet, obviously, we started collecting more data, and that's one of the main reasons why AI models work as good. So that's how we got here, but it's not new at all.
And maybe for some of the people listening, like an LLM primarily functions by using probability to predict the next word within domains. Have I got that right? That's always been my understanding.
So maybe I'll take you through a bit of history, which I think it's quite interesting, like to understand why is it called artificial intelligence? Like, is it actually intelligent or what's going on? Because I'm just saying it's a mathematical model. So the thing is that it was inspired in the way the brain works, because at the beginning, scientists said, if we can mimic how neurons work in the brain, maybe we can build an intelligent system as the brain. But definitely right now, we do call the models neural networks. That's actually the model behind the LLMs. But it's not like the brain. The brain has chemical feedback loops, quite complex. Actually, what neurons do in this neural network in large language models, it's just basically a mathematical function, lots of neurons connected to each other. Each of them represents one mathematical function, and that's it. And it's layers of them. But the important thing to understand here is that what LLMs do, they're not autonomous, they're not thinking, because you would think that artificial intelligence means they are thinking, but they're not. They're just based on a probabilistic model. They're just computing the likelihood of the next word. So what's more likely to be after and what's not as likely, and then that's it. The thing is that it does look as if it was very intelligent because it is trained in, as we mentioned, massive data.
And that makes it seem like magic. And I think that's why it scares a lot of people. But I think once you get a little bit of insight into, like you said, it's grounded in mathematics, like a lot of our technology today, like how a computer works, it all draws inspiration from nature, like the brain as a thing, and we try and emulate it, but it's got limitations to that. And so that's one of the things people seem to get wrong, is they think it's super intelligent, but it's actually just really good at particular tasks and solving particular problems.
I think that point is quite interesting because most people talk about AI from the fear perspective, probably because of mass media for movies, Terminator, like machines are just going to take over the world. But if you talk with AI developers, I mean, we know how it works. We talk from an understanding point of view, and it's maths. So yes, I guess that in media it's normal that it's highlighted the cases where AI didn't go well. For example, this law case where there was a solicitor that was citing judgments that didn't even exist because he was using an LLM. But I don't know how many, I mean, I've heard so many people talking about this, but not as many talking about how you can use AI for drug discovery, for example, which is a massive thing, or for precision medicine, for making sure that you get the treatment based on your specific characteristics and get, for example, pills that are printed in 3D with the components exactly that you need. So I guess it also makes sense to like highlight what is it actually very good at, and in some cases it's better than humans in some tasks. So what I would say about the tasks that it's quite good at and where it's not as good is automating those tasks that you do repeatedly the same thing, or that you have to review a high volume of data.
All things that actually relate to clinical negligence litigation. You think about sorting and collating records, that pattern recognition is highly repetitive, dating records highly repetitive. And so, yes, there happens to be a lot of application within our domain that we work in, which is partly why we are so passionate and excited about this.
The tasks at which AI is quite useful, as we were saying, is for high volume of data, summarizing, reducing admin load, but still having humans to interpret, to sense check, to apply the judgment that is very relevant, specifically in our domain, where there is a lot of expertise that's required. So yes, that's where human in the loop, for example, would come in.
And this is a term some listeners might have heard, because it is something that gets referenced a lot with, especially like in our domain where it's sensitive data or sensitive decisions that are being made. You do need to have that human in the loop. It just happens to sound really catchy as well. I love saying it. But it also brings me to something that we've heard quite a lot over the last few interviews that we've done for new team members. We ask them sometimes, what is it about AI that you don't like? And they all say, don't like it when people think AI is a golden bullet, or that it can solve every problem, or even worse, when people think that you can throw an LLM at a problem and that's going to solve everything out there. I understand that because it kind of looks like it can, because it's so confident in its prediction a lot of the time. You don't know when it's hallucinating, which is the other term that is used a lot, or you don't know when it's just giving you rubbish. And that's maybe also another misconception from people, is that AI is always right. Anyone can fall into that trap. You know, in Google, if you put in a search thing and that first block that it gives you nowadays, like the AI summary of your search query, I just assume that's correct. But like you do have to think about it critically and question it. Don't always assume that AI is giving you the right answer.
Yes, definitely. I think that's one of the most important points for people to think about when using AI. And I do understand why it's a bit difficult to know, because most of the tools that we use, they're deterministic, they're not probabilistic. So you're not going to start thinking like, oh, is the calculator telling me 1 + 1 or this multiplication, is it correct or not? Like, you just trust the calculator. And normally you just trust the tools that you're working with, Excel, spreadsheets, whichever tool that you use. But here, it's a probabilistic tool. It's not a deterministic tool. So you can't trust it blindfoldedly. So that's something that I always tell to the team. AI will fail. AI is not 100% accurate. That's something, if someone tells you that AI is 100% accurate, then you should not trust what's going on there. Maybe it's not evaluated correctly. So the important part to do when you're implementing AI is making sure that you have the guardrails, that you mitigate the risks, or that you always have the path in which you can identify if one of the answers is not confident, and what to do with it. So, for example, something that you could do with it, that it's being done widely across the industry, is if an answer from AI is not confident, then route it to a human. And that's where human in the loop would come to. So this edge case scenarios, a human is reviewing them. Of course, a human can't review every single one of them, but the ones that you flag. And then based on that feedback from the human, you can actually loop it back in to the model to every time make sure that it's improving. And that's one of the most important points as well to understand with AI, is that it's not static. It's not just like you build AI, throw it out there and forget about it.
You need to invest in it continuously and have those feedback loops to strengthen the models and maintain it. And I often hear talking about like data drift and things like that. That happens over time, especially when new LLMs are released. You first need to put it through its paces in terms of like what results it gives, because you don't know if the probabilistic element of it has now changed based on the new sort of training that it's gone through from the vendor and all of that. Would you also say like limiting the data set that the LLM, like through something like RAG or whatever, is also a kind of guardrail where you're reducing its sort of data set that it's pulling from?
So LLMs, you can think of them as like base models that anyone can use for whichever use case. But if you want to make it more specific to your use case or to your domain, to your industry, there are several ways you can do that. So for example, RAG, as you mentioned, it's a framework that makes sure that the LLM is grounding the responses in the documents that you are providing, which is very good at mitigating that risk of hallucination, because you are enforcing the LLM to return an answer with the corresponding source. If there's no corresponding source, then it can't generate.
And a RAG is not a piece of cloth in this case. It stands for
Retrieval Augmented Generation.
Which makes sense if you think about it. You retrieve something, you augment it, and then you generate from that instead of using the wide data set. Yeah, I think that covers that myth, what the reality of AI is versus what people think. Should we move on to the next one? Another myth is about data. People automatically assume with AI that more data automatically means better results. What are your thoughts on that?
So actually, there is a phrase that is used quite a lot in the domain. It's garbage in, garbage out. So even if you have a lot of data, if the quality of the data is not good enough, or for example, you have contradictory data, or your data is very imbalanced, so you have lots of examples about one thing, but few examples about another thing, then that will affect how your model performs. And it's very important to think about, so the models are learning from the data. The data is the base of the models themselves. But previously, like some years ago, that was one of the main things. Looking into data, most of the time would go into data wrangling, data science. Now it has evolved. So there's actually quite a wide variety of models that you can choose from, or techniques, depending on the amount of data that you have. So for example, if you happen to have a small data set, you can always do data augmentation, which means that you're just generating synthetic examples using AI. That's one of the things that you can do. Another thing that is widely used is actually, if you don't even have a data set from the beginning, you can just use an LLM that has already been trained widely on a massive amount of data, and you just give it a few examples in the prompt, and that's it, which is called few shot learning.
I think it's also interesting how people don't often know how big of a job it is to prepare the data. Data engineering as a particular area of AI development, and how you have specialized people who do that as a job and prepares the data for ingestion to make sure that everything is high quality. Especially with the kinds of data in the clinical negligence world, so much unstructured data, written notes, things that don't always make sense. While computer electronic records are very easy to OCR, like making sense of them, because there are so much repetition in them, is also a bit of a challenge, I think.
Yeah, so I would say that actually poorly organized data actually generates a risk. So there's lots of articles and actually in our own experiments internally, we've seen that, for example, when there's a very long document and you just feed the entire long document to a model, it will only look at the beginning and at the end, and it will be very and then everything that's in between, it will just ignore it because it's easier. So there are some techniques, like you want to chunk it and you want to look into the different subdivided parts of the medical records, for example, or generating chronologies. That's something that's extracting structured data from the unstructured documents themselves, which have also been demonstrated not only in our domain, but in most of the domains, that improves the response of the models. Because if you have, for example, a graph that's representing the relationships in these unstructured documents, or if you have, as I mentioned, the chronology, then you have the relevant bits of the document to reason about with the model, instead of feeding it all into the model, and then that generates probably hallucination. Why it's very important that you keep a data set, and every time that you create a change, you test it on that data set, so you know for that same data how every single configuration works. And that will inform if you can take that new configuration, that new model, to production or not for your given use case. And it is quite important in terms of the monitoring of the model. As you mentioned previously, there can be data drift. They can be different types of drift. But what data drift means is that, let's say you created a model 2 years ago for creating chronologies, for example. But then medical records have evolved, and the way that the model was looking at your data now has to be like configured differently, because the data is tweaked, because the data is looking differently. So that is the data drift, and then your performance might drop, not because the model is not good, but because your data is changing, so that configuration.
This is also where, at this point, I think maybe where you would start changing like the temperature of the model and things like that, and temperature defines like it's how creative the model is with its outputs, right? So the higher the temperature, the more creative. If you want a more deterministic result, you would like lower the temperature. I just always find that concept really interesting.
So about temperature, actually it is quite useful. One of the ways that you can mitigate hallucinations, because when you have a high temperature, it means that you are allowing the model to be creative to, for example, if I ask the same question, it will always be a very different answer if I have a high temperature. But of course, in our domain, we don't want that to happen. You don't want chronology to have different kinds of timelines for the patient. You want the exact same timeline every time that you run the model. So configuring the temperature to a lower one helps. It's one of the ways you can do that.
Right. And is that all the sort of things about data, like in maintaining and monitoring data that you wanted to mention? Because I know there's also, what kind of metrics do you use to monitor the models? For instance, like precision and recall is one of them that you run against data sets. Perhaps is there any other that we might know about?
Yes, actually, there's lots of evaluation metrics that you can have depending on your use case, depending on the task that you're working on. But for example, what gets tricky, and I think it's quite interesting, is when you don't know what the correct answer is. So sometimes you actually don't know. When you know the correct answer, it's very easy to evaluate because you just compare correct answer versus the answer that I gave and how much they overlap with different kinds of metrics. But when you don't know that endpoint that you're trying to get to, that's where, for example, LLM as a judge would come in. Your favorite, exactly. So LLM as a judge is just using AI to evaluate AI. So a model does a prediction, and then you use another model to check if that prediction makes sense. And if you want to make it even more robust, you can do another layer, which is, again, human in the loop. So you can have some of the cases being reviewed by humans to evaluate how it's performing. Because even if it looks correct, or if the model is confident about it, it doesn't mean that it is correct. It's not that you can't trust AI. It's just that you have to make sure that you have the guardrails, that you mitigate the risk, that you correctly identify them, and that your entire framework is built understanding that AI will have scenarios in which it will fail, and how should we act on those points, and how should we identify them. And there is quite lots of techniques.
That's included in the responsible use of AI. It's not, responsible use of AI isn't just like, should we be doing this? It's also knowing how to do something in the proper way so that you don't get incorrect data or incorrect answers. This kind of ties into our next myth, since we're delving a little bit deeper into how the models sort of are tweaked and things. AI is a black box no one understands. And I know there's a particular area that is really applicable to this, explainability. What is explainability first before we carry on?
So explainability in AI specifically is about putting it into simple English terms. It's just understanding why AI made a prediction or took a decision. So it's not just saying, for example, this case is supportive of breach, but saying this case is supportive of breach because of this, this, and that. Supported, grounded, as we mentioned before, grounded in this not nice guideline. So it's basically giving humans a way of understanding what went on inside that black box. So even if you don't understand inside the AI model what is going on exactly, because, for example, if you're using an LLM, you didn't train the LLM necessarily. Maybe you're just using a pre-trained model, like when you just talk with ChatGPT. Just the important part is that you understand why it's making a decision or the other. And then, based on that, that's where you need the human to reason if it makes sense or not.
Related to all of that, the biases and fairness within AI, is that something you consider to be a part of the sort of responsible usage of AI in terms of like explainability and interpretability?
So bias is actually very relevant in the explainability, or at least monitoring of the models after you get them to deployment, but also when you are designing your model, because you have to make sure, like, building responsible AI means that you have to make sure that you understand the limitations of your model. So just giving you an example, the way that you would identify if there's one of the ways that you would identify if there's a bias in your model is if you segment, for example, your results for females versus males, and maybe you realize that for males your performance is much higher than for females. Which might mean that by segmenting that your model is not doing well for females. So that's a limitation that you've identified. That's a bias that your model has. And then once you identify it, there's several ways that you can mitigate it.
Bias comes from the data that the model was originally trained on being lopsided or just unintentionally favored towards certain demographics or certain concepts, and that only comes out when that model is being applied to certain domains.
So the thing is that the current data that the models are training on, they're mainly just generated by humans, and we just inherently have bias. So if you just try to replicate the data that it's being trained on and just use that, then of course it will have bias because that's the data it's seeing. But we want to be able to generate systems that do not augment and that do not further take that bias into industry. And that's actually one of the improvements of propagate. Yes, exactly. So you don't want AI to do what a human would do. I mean, if you're using AI, it's because you want to improve over what humans are already doing. So humans are biased. We want our systems not to be biased. So definitely you won't want to propagate on that data. Sometimes you can't change the data, so you just have to change how the model is working with it. Sometimes you can actually just modify or tweak the data to understand. But there's actually very interesting research papers and industry work around the bias in, for example, case judgments. Depending on, we were talking, it was yesterday, I think we were talking about the bias in terms of how judges communicate for women with domestic abuse and how that affects the outcome of the judgment.
So interestingly enough, you can use an AI model to detect bias in content, even though AI models have their own biases. If that model's been trained enough on a different data set, you can use it to go, oh, there's something not quite right here. It's favoring a certain party or a certain demographic. And that's a really useful application in AI, I think. I've really enjoyed our chat today. I think we've covered like a lot of the foundational elements of AI as it's relevant today. I think also relevant in our industry. And I think some of the myths that we've discussed, those are things that are front of mind for a lot of people in the medical and legal fields, and combine those two fields as well. Do you want to reflect on some of the things that we've spoken about?
If you were going to just have a couple of takeaways from this conversation, I would say that AI is a tool. It's not a decision maker. It's not the solution for everything. It's just a tool, and we have to make sure that we use it responsibly. That we have the safeguards, the guardrails, and that we mitigate the risk. And that's actually the important part, to make it trustable to go into production with these models. Still keeping humans accountable in some of the domains that are highly sensitive and highly regulated. I think that the regulation here, it's quite important to make sure that when you are taking AI to production, that it is meeting with the bias that we mentioned, with the grounding, not hallucinating, that it's properly being monitored, and actually building it with users. We're not building AI just because of the hype, but building AI that it's actually useful for society and for the end user.
You know what I really like about that statement is that I always think with AI, people can be preoccupied with the technology or the hype, and not putting the use case first. I think it's really important for a business to identify the use case and then the technology and how it can actually work. And that's when I feel you get really high value applications of AI. Something to say like good tech is built with users, not imposed on them, is also something that we believe in.
I would just throw in a phrase that I really like, and it's if the only tool that you have is a hammer, then you tend to see every problem as a nail. So definitely, AI is not the solution for everything. You might not need to automate every single thing. So making sure that you put the human in the center, the user in the center, that's key.
Also enjoyed like the expansion on the definition of responsible use of AI, that it's not just ethically inclined, like, oh, is this something we should be doing? But it's also a lot to do with ensuring that there's guardrails, as you said, that the data is properly maintained over time, and that the solution isn't just built and forgotten about, with the potential to really affect the subject matters or the data subject matters that it's being been based on or intended to improve the outcomes of. So I hope that's been informative. And like I said, it's always helpful to reflect on these things. It's like a little refresher for us every now and then, just to just to talk about it.
Thank you for the interesting discussion.
That's been a pleasure. Thank you.